Okay, so I'm trying something new here. I'm going to be teaching some earth science. I'm usually known as your math guy because I'm the one who throws a bunch of right triangles around and creates a beautiful structure. But I guess today I want to try volcanoes and some science. Probably we're going to stick with science, math, maybe a little social studies. I don't think I'm going to do LAL. I mean, what am I going to do? A literary review on Fahrenheit 451? Maybe? Let's just stick with science and math. We're probably only going to be posting a bunch of math, maybe a sprinkle of science. So today's lesson in science is on volcanoes. So what is the definition of a volcano? So let me draw my best volcano. See, these are the right triangles coming back because I just did a video on right triangles. So I'm going to draw my beautiful volcano structure. A volcano is just a vent in the Earth's crust. In the Earth's crust, where? So let me say this all because I'm writing it down at the same time. A vent in the Earth's crust through which melted or molten rock flows. What this is saying is, Ross, a vent in the Earth's crust through which melted or molten rock flows is known as volcano. Have a little vent in up molten rock. All this is flowing inside this vent. And this is what we define as volcano. What geologists define as volcano. And then melted or molten rock. Let's look at molten rock for a second because this is important. Molten rock comes here. So molten rock under the Earth's surface now. Now, this is, molten rock is under the Earth's surface, so, like, in this vent under the Earth's surface, it's called a volcano, but, no, it's not called a volcano. It's called magma. This molten rock we find underground is known as magma. So, that's just, like, getting some vocabulary words that will come up again and again. So, something to know is volcanoes are all around the world. So, some places may have more volcanoes than others, like Hawaii. But, as we'll see, Hawaii is a special case, because I'm guessing we all have knowledge of plate boundaries. Convergent, divergent, and transform. Transforms don't come up again, really. It's in earthquakes, which is the lesson before. But divergent and convergent help create these volcanoes. But the issue is, Hawaii and some other places are an exception to this boundary rule, where volcanoes are created. So volcanoes also have a lot in shaping the Earth's surface. So they can create mountains, create new crusts, or even leave a path of destruction behind. And then this allowed scientists, well, maybe not just that, but scientists have learned that the movement of Earth's tectonic plates caused the volcanoes and caused the eruptions of these volcanoes. So first things first, volcanoes can form along convergent plate boundaries. So, when we have two plate boundaries, remember that the denser one always sinks. That is a hideous boundary. The denser one always will sink. Ooh, I don't know, especially, okay. I'm sorry, but that is hideous. There is a hideous example of a subducting boundary. And it's not my fault. I can't draw, okay? So, here, I'm honestly just gonna look one up and take that, because that's probably better. So, oh, wait, this is actually really good. Notice how this boundary is going under. Remember, two boundaries that are meeting up is called convergent boundaries, which is the boundary we were just talking about. So, convergent boundaries, a denser plate sinks. So, this plate that is going down is our denser boundary. It's getting pushed or subducted under the other. And this is getting subducted into the mantle. And then, because the plate is subducting, the energy below the surface in the fluids, so the fluid's driven off this plate, So maybe these are underwater or something. So the fluids that are on the plate that are driven off with the with the thermal energy, which is already below the surface. So wow, I'm showing a lot. Let me just recap. There's thermal energy under the surface, and there are fluids that are being pushed off the plate. Well, they're being driven off the subducting plate, because that's the one going underground into the mantle. And these two things melt the mantle. And when they melt the mantle, magma is created. So, melted mantle really implies magma if under this plate boundary. Then magma is less dense than the surrounding mantle. Then magma is shown to be less dense than the mantle. So this magma is the melted mantle in the spot where the subduction is happening, really. Because it's less dense than the surrounding mantle, it rises through cracks and crusts. Rises through cracks in the crust. And because it rises through the cracks in the crust, you know what it creates? Volcano. So really, melted mantle implies magma. And this magma is less dense than the surrounding mantle, which implies it rises through the cracks in the crust, and it implies volcano. And then molten rock. So this magma is not coming up to the surface through the volcano. Is also known as lava. So lava, the rock erupted. So I'm probably just going to split this into two parts, I'm saying. First one will be all about boundaries. Second one will be about the types of volcanoes. And then next one we learn about is divergent boundaries. Well, next one that includes volcanoes are divergent boundaries. Next one. Okay. Who cares? So I'm going to find another diagram of divergent boundaries to draw. Because that wasn't that great. Okay, so when two boundaries are diverging, they're just going away from one another. So here's my best image, okay? Let's say these are our two plates, and under here is a bunch of rock and stuff. Who cares? So as these two plates start to separate, so let's call this plate 1 and plate 2. As plate 1 and plate 2 start to separate, magma is starting to rise through the crust that forms between them. So as the divergent boundary, so they get pushed away, the plates, and a new crust starts to form between them. Let's say this is like our new crust. I'm trying my best here. I can't draw. And with the new crust that's being created, there are sometimes little openings inside the crust. I don't know how accurate this would actually look. So I'm just drawing it out so you understand the idea of how it works. Don't actually expect this to be how it would look, okay? Because it's a little bad. So here's the new crust. Here's an opening in the crust. And through the opening, magma starts to spill through. So we just ignore this diagram for a bit. So what this diagram is really saying is when two plates start to diverge, so the new crust that's being created through the diverging, there's new crust that's being created through the diverging boundaries, which we know from plate boundaries. But then there's little openings in the crust that sometimes forms between them. And through these openings, magma starts to rise up. But then what this creates, it doesn't create a volcano. It creates a mid-ocean ridge. But mid-ocean ridges do matter. Because across mid-ocean, because 60% of all volcanic activity on Earth occurs across these ridges. Why? Why did it do that? Myth. No. I don't even know what myth means. Mid. So 60% of all volcanic activity occurs across the mid-ocean ridges. So we're trying to understand mid-ocean ridges and how they form. So because of this volcanic activity. And the last one we're going to look at, well, the last way it can form Well, I guess how mid-ocean ridge is not really how it forms, but Hawaii. We're just going to draw a bunch of on my head, okay? I'm not making it detailed, but let's say this is Hawaii. So Hawaii is nowhere near a plate boundary. And plate boundaries are usually where volcanoes form. So why does Hawaii have so many volcanic islands? So first things first, we have to learn a new definition. So a hotspot. Hawaii is known as a hotspot. There are areas of volcanoes that looks so... My handwriting's so good, it's messing everything up. My handwriting's really bad. And I'm not trying to do anything to stop it, okay? But when volcanoes are not associated with these plate boundaries, these are what we call a hotspot. So Hawaii, all those volcanic islands, Hawaii is really known as a hotspot. So geologists hypothesize, which really means they don't know, but that's their best guess. Well, that's like ideas they have. But geologists really hypothesize that hotspots originate above a rising convection current, which is found deep inside the Earth's mantle. So remember, convection currents is the forces that move the plates. And so they're guessing that these convection currents start to rise from deep in the Earth's mantle. And it creates these hotspots. And then these rising convection currents, rising currents of hot mantle material, because remember, convection currents, the hot mantle material, this is what they call plumes, the rising currents of hot mantle material. So we have a little diagram, which... Here's my diagram. So that is how everything is going. So let's say this is our newest island. This is Hawaii. I don't know why I added like Hawaii. Who cares? But notice how it's moving farther and farther away. These islands. They're moving it like why did it do that? Moving like this. All the islands are moving in basically a path like this. So this really is illustrating how a new volcano forms as a tectonic plate moves along a plume. So a tectonic plate will first move along this plume. And when this plate moves away from the plume, the volcano becomes... Hold on, there's something... Okay. So this is really showing how the tectonic plates move over the plume. So I'm just going to repeat that because something happened. So these plates movements is creating these new islands. And if you remember, plates movements can create these new islands. Then as these plates move away from the plume, so the plume is the rise of convection currents, which would probably be in the area where Hawaii is really created. And then these plates are starting to move away from these plumes. So what that's mean is the islands are moving away from the plume and creating this southeast little area. Then when these plates actually move away from the plume, the volcano becomes inactive too. So here is the plume right now. It's in Hawaii. It's at Hawaii. So this means because of the rise in mantle, it means the volcano at Hawaii is dormant. But the plates that are moving away from the plume, moving these islands away, those are dormant or inactive. Because they're moving away, there's no rising mantle material. Hawaii is a volcano area, which is active. So the hotspot is at Hawaii right now, because that's where the rise of convection currents is. And then plate movements, all of that, moving the islands. So the oldest volcano is going to be right here, because this is the farthest away from the plume. The newest is Hawaii. So it's always directly above the hotspot. Have a little more to get through. Sorry, I'm just checking. Okay. So let's say, I'm not going to even try to draw North America. I'm not gonna try because it's not gonna look good. So the Ring of Fire, and you may or may not have heard this before, but around the Pacific Ocean. Oh gosh, let me draw my best Pacific Ocean. I'm literally just gonna draw a square and call it the Pacific Ocean. Let's say this is the Pacific Ocean. Let's just say shh. The Ring of Fire represents an area of earthquake and volcanic activity that surrounds the Pacific Ocean. So let's say these little red dots are the Ring of Fire. Okay, it doesn't actually look like that, but we're just pretending. So these red dots represent the area of volcanic and earthquake activity that occurs around the Pacific Ocean. And this is where most of this activity is actually occurring. It's a huge area, and the reason of this is because if you were to compare, so let's say you actually had a map of the Pacific Ocean and Ring of Fire, if you compared the location of active volcanoes and the plate boundaries, you'll see that these volcanoes are mostly along these boundaries, these convergent and divergent boundaries. About all the volcanic activity around the Pacific Ocean, this Ring of Fire, you could compare it with the actual plate boundary, and you see a connection between the plate boundaries and where the activity is. Volcanoes are mostly along convergent boundaries, convergent boundaries, but they're also located across divergent or also hotspots like Hawaii, the Galapagos Islands. Okay, I actually did not pronounce that anywhere near. And the Yellowstone National Park even. So, isn't that cool? Yellowstone National Park is a hotspot. But the Yellowstone National Park also has this huge supervolcano. And we'll dive into depth of supervolcanoes, but all I'm saying is, if it erupts, it will not be good. But that's the Ring of Fire. And then this last chapter is about the U.S., so... But not everybody's in the U.S., so we're just gonna skip over that. But yeah, that's really Ring of Fire, all of that. So this is really part 1, and the next part will be about volcano types, eruptions, all of that cool stuff. So, is it that fun? I hope it is. So yeah, that's really it. That's Volcanoes Explained, part 1. So, this is my first science video. I think I did fine. That diagram is not, you're seeing nothing. This is the conversion diagram. So I guess just a lot. So make sure you just try remembering this. That's all I need you to do. If you don't remember it, I guess I don't care. But if you remember it, you'll probably do better in whatever you're trying to learn. So, yeah.